We're now going to discuss Chapter 12 of the California Plumbing Code, which covers fuel gas piping. Chapter 12 covers fuel gas piping systems with capacities up to 5 psi. The fuel gas piping system that we're going to be discussing only includes the gas piping system from the point of delivery to the appliance connection, whatever that may be, within the building. And typically the point of delivery is the outlet of the gas service meter assembly outside the building or the structure itself. This slide depicts a simplistic view of the material that's going to be covered in Chapter 12. It's essentially everything on the outlet side of the utility company's gas meter. Chapter 12 does not cover any of the responsibilities that the utility company or the gas supplier is responsible for, which would be everything from the meter to the uphill side, basically, of the meter, or the supply side of the gas meter itself. Chapter 12 starts right off the bat with discussing inspection in section 1203.0 and basically identifies some very simplistic and obvious requirements for inspection of fuel gas systems. Obviously, all excavations have got to be kept open until the piping has been inspected and approved. And the code distinguishes between two types of fuel piping inspections. The first one is a rough piping inspection, which is basically going to be performed after the piping is installed, but prior to covering and concealing any of the piping or attachments or connections to any fixtures or appliances. It basically verifies that the pipe size, material, and installation are code compliant. The final piping inspection is performed after the piping is actually covered, concealed, and prior to the fixture or appliance or shutoff valve installations. Associated with the inspection of fuel gas piping systems is the requirement for a certification being issued prior to the gas supplying company pressurizing and installing gas into the system. Basically, once the final piping inspection has been verified code compliant by the product inspector, the authority having jurisdiction is permitted to issue a certificate of inspection. The product inspector obviously acts on behalf of the authority having jurisdiction in this area, since they are providing inspections that are required per the Division of the State Architect's policies and guidelines established in the California Administrative Code and also various education code references. The certificate of final piping inspection must be issued to the serving gas supplier, and it's important, obviously, that the product inspector issues this certificate, and there really is no formal form or format for the issuance of this certificate. However, it does indeed need to be in writing. It needs to be dated, and it needs to specifically identify what its purpose is. And the product inspector would complete this and distribute this to the gas supplier. Obviously, this particular document must be retained by the product inspector in the appropriate folder within their job file. It goes further to say that it is unlawful for a serving gas supplier to turn on fuel gas or a gas meter until this certificate of final inspection has been issued. So that basically describes the importance of this certificate and should drill that fact and importance home to all the product inspectors. Again, similar to all of the previous sections relating to installation of a variety of plumbing systems. Materials and joining methods are addressed initially in each of the chapters and also in this chapter. With respect to materials use, cast iron piping is not permitted to be used for fuel gas piping systems. Standard weight, which is Schedule 40 minimum steel or wrought iron, is acceptable materials to be used. Copper, brass, and aluminum alloy materials are restricted, however, due to corrosive concerns. Metallic tubing is also restricted from the perspective that copper, brass, and aluminum alloy materials and some steel tubing is also restricted for similar reasons, corrosive reasons. Corrugated stainless steel tubing, which is very commonly used for flexible joints within systems just in front of appliances or equipment that are being served by the gas supply system, it's must be listed. And we're going to see this particular terminology used throughout and very frequently. It is abbreviated CSST. Polyethylene plastic pipe, tubing, and fittings are also acceptable for fuel gas distribution and must comply with ASTM D2513 and must also be marked ASTM D2513 and gas. Heat fusion joints are typically made on polyethylene plastic pipe, and these particular joints have got to be assembled and made by qualified personnel using qualified procedures, including the manufacturer's instructions. The installers, principally the fusion joint makers, must be certified in making these joints, and it is certainly appropriate that a project inspector would ask to see the certifications for each of the fusion joint technicians prior to them preparing and performing any fusion joint assemblies. As a general rule, PVC and CPVC pipe, tubing, and other fittings are not permitted for fuel gas distribution. However, PVC is an acceptable material to use outdoors for vent applications for regulators, as long as those assemblies comply with UL 651. This slide shows some typical polyethylene joint configurations that are made. The one on the left is a butt fusion joint. The one in the middle is a socket fusion joint. And the one on the right-hand side is called a saddle fusion joint. And these are the typical joint assemblies that we would see created on a project using polyethylene pipe. Gas pressure regulators are also required on projects. A line pressure regulator or a gas appliance regulator must be installed where the gas supply pressure exceeds the operational design of the actual branch supply line or the gas appliance, or it exceeds the design pressure limits. This is going to be predetermined by the design team and will certainly be called out on the plans and the specifications, and submittals for these devices will also be available for review and approval for inspection of these devices upon delivery to the job site. These particular regulators have got to be listed. They have to remain accessible. They have to be protected from any kind of physical damage. In addition, overpressure protection may be required, and independent venting of the regulators to the outdoors may also be required when installed in an indoor situation. CPC sections 1208.9 and 1208.10 are new amendments to the California Plumbing Code, the 2019 edition. 1208.9 addresses overpressure protection devices, which are now required. Specifically, that overpressure protection devices are required or the actual fuel gas that's supplied exceeds 2 psi. 1208.10 identifies some additional overpressure protection device requirements. One of them is the fact that these overpressure protection devices are required to limit the gas pressure to 2 psi max to each appliance in the event of some sort of catastrophic line pressure regulator failure. The overpressure protection device has also got to be adjusted per the appliance manufacturer's installation instructions, which again is very common language with respect to any manufactured component that requires installation. These devices have got to be capable of independent operation, and the failure of the primary pressure control device is also required to be detectable. Chapter 1209.1 discusses excess flow valves. Excess flow automatic gas shutoff valves are very rarely seen on DSA projects. They're very rarely seen at all. However, they will be required on a case-by-case basis based on local jurisdictions requirements or requirements that the design professional has placed on the project itself. Now, when these excess flow automatic gas shutoff valves are required, the valve is required to be sized and installed in accordance, obviously, with the manufacturer's installation instructions. They're required to be listed to CSA Z21.93-2017. They have also got to be manufactured by a DSA certified company. And because of that, they will be identified by a special tag that verifies compliance with DSA manufacturing requirements. We're going to talk now about the requirements for fuel gas piping installed underground. Number one, approved clearances need to be maintained from other underground structures, which makes complete sense and is obvious. Further, a minimum 12-inch cover is required, or 18 inches where external damage to the piping system itself is likely to occur. Steel fuel gas piping installed underground must be protected against corrosion. Galvanizing is not an acceptable protection of underground gas piping, and this is not a new requirement, but it's a new area where this requirement has been decided by the model code to be provided. It goes further to say that acceptable protection methods are the fact that piping that's constructed of corrosion-resistant material is accepted underground, obviously, and piping that has factory-applied electrically insulating coatings are also acceptable to be installed underground. And that deals specifically with steel piping that's installed underground. Section 1210.1.3 of the California Plumbing Code has been expanded significantly with the 2019 edition in order to further clarify cathodic protection measures that are now required to be initiated for some steel type piping. So cathodic protection systems must be installed based on parameters that are established. Okay, this includes sacrificial anode testing parameters that are identified, cathodic protection test failure protocols have been identified, impressed current cathodic protection inspection and testing requirements are established, test documentation retention requirements are addressed, Insulation of dissimilar metals is also discussed and detailed, and cathodic protection of steel risers is also required. So all of these issues are brand new to the 2019 edition of the CPC and are addressed in great detail. So they're identified here in red font and underlined to bring these to the attention of the project inspector. Continuing with fuel gas piping installation requirements, all piping must be protected from freezing when freezing is a concern. Piping that is penetrating underground foundations is required to be sleeved with the annular spaces sealed, preventing gas and water entry. This is again very common. Piping underground beneath buildings must be encased in either approved conduits designed for imposed loads or by a listed piping encasement system. And we're going to discuss that in more detail in just a few slides. For fuel gas piping that is installed underground with one conduit or one end of the conduit terminating outdoors, there are a couple of requirements. The requirements are based on whether or not the conduit extends into the inside of the building or whether it extends into the outside of the building. So for the conduit, which extends in the inside of the building, it's required to terminate in a usable and accessible area, and the space between the gas pipe and the conduit itself is sealed. In the outside of this particular conduit, it's required to terminate 4 inches minimum from the building. The conduit is required to be vented outdoors above finished grade level, and the conduit is required to be protected from water and insect entry. Obviously, it's going to be sealed if it's outside. Now, in situations where the gas fuel piping begins in an indoor location and also terminates in an indoor location, there are a few requirements that are a little bit different from the previous installation with conduit initiating in the inside of a building and terminating in the outside of the building, and they are as follows. Each of the ends, which are terminating in an interior space indoors, must terminate in a usable and accessible area at each end. The spaces between the gas pipe and the conduit must not be sealed, and the installer must be aware of sleeve requirements for gas piping located under covered walkways or canopies. Section 1210.1.7 addresses plastic piping in that it is permitted to be installed underground and outdoors only. So you will never see plastic piping used for fuel gas distribution that is exposed above ground, ever. It is not permitted for obvious reasons. As an additional clarification, and is basically newly added to this particular section of the code, tracer wire that is required on plastic piping is supposed to be insulated 14 gauge copper wire or another approved product to facilitate locating. Again, as we discussed previously, there was an internal code conflict with the size of the wire used for tracer wire in plastic underground plumbing applications. So that conflict has been eliminated by identifying that only 14 gauge copper wire or other approved products are permitted as tracer wire for locating underground plastic plumbing piping. This particular slide shows an actual installation of a fuel gas piping system where it is basically the type that has conduit which terminates inside a building and outside of a building. So as you can see on the right hand side, this is the actual plan description of what needs to happen with the conduit that is protecting this particular piping. And on the left hand side you can see that the installation matches. So this is more of a visual description of the words that we described just a couple slides ago, showing an application where you've got the conduit initiating in an interior space and exiting in an outdoor space. Okay, now we're going to discuss some of the requirements for fuel gas piping which is installed above ground. This particular piping has got to be separately supported, and Table 1210.2.4.1 describes acceptable support connections and materials and sizes permitted to be used for this purpose. The above ground piping is required to be sloped 1/4 inch per 15 feet minimum to prevent traps, any type of trap that may be created by condensation inside the piping. The piping is required to be protected from physical damage and corrosion, either with an approved coating or wrapping when required. The annular spaces must be sealed at the exterior wall or sleeve penetrations, obviously in order to prevent rodent, insect, and water entry. And this is a very common requirement for any type of plumbing or electrical penetration, for that matter, into a building. Continuing with above ground fuel gas piping, it is permitted in the accessible space between a fixed and a suspended ceiling, even when the space above the suspended ceiling is being used as a plenum for the air handling unit system. No valves, except for the appliance shutoff valves for vented appliances, are permitted in the accessible space above suspended ceilings. And a new code amendment, which is 1210.2.4.3, identifies that gas piping on rooftops elevated above the roof surface must be supported per table 1210.2.4.1. And again, this may appear like it's a new code requirement. It is not a new code requirement, but it has been relocated in its entirety to this particular section in the code. Section 1210.6 discusses drip traps and sediment traps. And it's important to understand the distinction between these two types of traps that are installed in fuel gas piping systems. Both types must be readily accessible for cleaning and emptying. Obviously, these are serviceable components of a fuel gas piping system. Drip traps are only required where condensate may collect. And of course, a drip trap is going to be identified by the design professional that has approved the system, and they'll be shown clearly on the plans where they need to be installed. Drips are generally not installed, and more specifically, they're never installed where the condensate may actually freeze and cause the gas inside of the fuel piping system to be plugged. With respect to outlets, they must be securely fastened. They must be capped or plugged gas tight, and that means with a threaded plug or a cap immediately after installation. Now, this is a very important concept and one that is not clearly understood or implemented on any construction job. And what that means to say is, once you've got fuel gas piping that is being installed and the routing of the piping is actually connected to an area, where it is possible for fuel gas piping to be introduced into the lines. As soon as the outlets are installed, for safety reasons, the outlets are required to be capped or plugged. Now, any unused outlets on the fuel gas piping system have got to remain capped or plugged for the duration of their existence. So even though you may have a situation where you have a bank of gas valves, if they're unused, if any of them are unused, they have to be plugged or capped after installation. So this is certainly worth paying attention to and reminding the contractor of this requirement during construction. And again, this is a safety measure. It's intended to not allow the inadvertent release of fuel gas into a structure. This particular set of sketches is provided to attempt to show the difference between two very common but also commonly misunderstood types of sediment and drip traps. This sketch on the left-hand side shows an approved sediment trap, and these are required at every gas supplied appliance or piece of equipment. And the thing to remember here is, if you look at this, if you look at how the gas is coming in from the top, and the gas is going to make a 90-degree turn to the left to go to the equipment. The reason this is considered a sediment trap is because any sediment that may be in the gas itself has to drop down into this receiving cap section. Gravity is going to cause that to always drop down, and you can see this cap is provided down here for maintenance individuals so that they may empty this or monitor this periodically. Now this sketch on the right hand side, it says wrong design, meaning it's the wrong design for a sediment trap. This is what we used to see that was called a drip trap, and the reason it was called a drip trap is because the way condensate forms in a pipe, it's generally going to migrate to the bottom of the pipe. So in a horizontal application like this, you could imagine moisture being in the bottom of the pipe, and as the gas is flowing from left to right, the moisture is going to obviously collect and stay on the sides of the piping itself, and it's going to migrate into the bottom of this nipple assembly here. However, the reason it is not an effective sediment trap is there's a possibility that sediment can easily jump over this small gap here where the nipple is transitioning down. So it's important to remember the difference between a sediment trap and a drip trap, with the understanding that sediment traps are always required and drip traps may be required depending on what the design professional charged with approving the actual plumbing system design has decided the project actually needs. This slide shows an image of a roof-mounted air handling unit, and it shows the fuel gas piping going into the side of the unit. And what we can see is a shutoff valve, and then a piece of or a section of CSST, and then a union after that, and then it looks like it 90s into the side of the HVAC unit itself. Now it's not apparent here by looking at this that there is a sediment trap installed. However, it is certainly possible and not uncommon that the sediment trap itself is installed inside of the unit itself, beyond what we can see inside a covered portion. So it is certainly advisable for the product inspector to pay close attention to this situation and to review the unit in great detail to verify whether or not the sediment trap is actually installed inside of the unit. And that's the reason why we don't have an externally visible or mounted sediment trap depicted in this picture here. Section 1210.9 discusses the requirements for manual gas shutoff valves. An accessible manual gas shutoff valve installed upstream of each gas pressure regulator is required. There are situations where an emergency exterior shutoff valve, one which is plainly marked and its location is posted, must be installed to permit turning off the gas supply to each building in an emergency. Also, a single identified accessible laboratory shutoff valve, one that is located in the laboratory or adjacent to the laboratory egress door, must be provided where 2 or more gas outlets are installed in educational occupancies. We'll see these in laboratories where you have a series of Bunsen burners installed at counters where classroom experiments will take place. Another very important topic relating to fuel gas distribution systems is the fact that the piping itself is required to be electrically bonded and grounded. Above ground portions of the gas piping systems are required to be electrically continuous and also bonded, ensuring that there is no piping that exists without being bonded or grounded, creating the potential for some sort of electrical shock potential associated with the fuel gas piping. The bonding jumpers have requirements as well. They must be connected to a metallic pipe, a pipe fitting, or a CSST fitting. Obviously, it has to be connected to some sort of metallic piping. The bond jumper must be a minimum of 6-gauge copper wire or equivalent. It is not permitted to exceed 75 feet in length, and the bond connection must be in accordance with NFPA 70, which is also NFPA 54, section 7.13.2.4. To clarify, the gas piping is never used as a ground conductor or an electrode, so it's important that it's distinguished as being bonded and not serving the purpose as a ground electrode. The gas piping system is never to be used as an electrical ground electrode. It's specifically to be bonded to ensure ground continuity between the piping in the system itself, and that's all. Earthquake actuated gas automatic gas shutoff valves are discussed in section 1211.7, and very similar to excess flow automatic gas shutoff valves. These particular gas shutoff valves are required on a case-by-case basis by local jurisdiction or the design professional. However, when these valves are required, the valve must be sized and installed in accordance with the manufacturer's installation instructions. They're required to be listed to ANSI ASCE SEI 25-16, and they must be manufactured by a DSA certified company. Again, similar to the excess flow automatic gas shutoff valves, they are going to be identified with a tag verifying their compliance with DSA manufacturing requirements. But again, these are installed very rarely, and they're going to be basically required by local jurisdictions. This is an actual photograph of a standard earthquake actuated automatic gas shutoff valve. Fuel gas piping is required. Fuel gas piping that's used for appliances must be connected to the building piping by one or more of the following devices or fittings. Rigid metallic pipe and fittings is acceptable. Semi-rigid metallic tubing and metallic fittings are also acceptable. a listed connector which complies with CSA Z21.24 or CSA Z21.75, and the restriction is only one of these may be installed per appliance. Corrugated stainless steel tubing, or listed non-metallic gas hose, complying with section 1212.3. Additionally, and this is new to the code to stipulate this particular requirement or allowance in writing, is that unlisted hose is permitted to be used to connect Bunsen burners to the gas supply in laboratories and educational facilities, and these installations must comply with section 1212.4. And obviously we do see these periodically in laboratory settings in schools. In situations where commercial cooking appliances are installed, which are basically mobile, that is, they can be moved or are generally moved for cleaning and sanitation purposes, there are some additional requirements. First of all, the appliance connected must be connected in accordance with the connector manufacturer's installation instructions. The listed appliance connector must comply with CSA Z21.69 requirements, and the appliance connector installation must be performed in accordance with the manufacturer's installation instructions. In addition to specific appliance connector connections that are required for fuel supplied appliances which are mobile and need to be moved periodically, these particular pieces of equipment need to be restrained so that undue forces or catastrophic failure of the connections to the fuel gas piping are not permitted to occur. So these restraining devices are required to limit the movement of appliances that have casters or are designed or intended to be moved periodically for cleaning or maintenance. These restraint devices must also be installed, of course, in accordance with the connector and the appliance manufacturer's installation instructions. Section 1212.4 is a new section, and it identifies injection burners or Bunsen burners, and basically restates that, as we discussed a couple slides ago, that unlisted hose is actually permitted to be used to connect Bunsen burners to the gas supply in laboratories and educational facilities. This particular photo shows a couple of interesting things. Number one, it actually shows a gas connector which is designed and installed to allow a gas-fed appliance here, which is basically a heating device for food. But you can see that it's a very special connector. It is flexible, and it's installed per the manufacturer's recommendations. Additionally, you can see that there is a restraining device, which is basically a long braided wire which is connected from the wall to the actual appliance that's intended to be moved periodically for cleaning and maintenance, and it's going to limit the amount of travel that will occur with the device during maintenance or cleaning. But also an interesting thing to note, if you pay attention to the manifold located on the wall where the actual gas shutoff valve is located, you'll see that there's three gas shutoff valves. One of them obviously connected up to the gas supplied appliance, but also two that are connected to nothing at all. And the interesting thing to note on those particular gas valves is the fact that unlike what is required, neither of those two gas valves have plugs or caps installed, as is required to preclude the inadvertent release of fuel gas. So that's something that, again, project inspectors should be fully aware of and check and remind the contractor of the requirement for those particular outlets to be plugged or capped at all times when not in use. As an additional piece of information, understanding what we just observed on the previous slide, appliances that are connected to the piping system require an accessible approved manual gas shutoff valve or a listed convenience outlet. These particular valves are permitted to serve only a single appliance. They're required to be installed within 6 feet of the appliances that they serve. They are certainly required, obviously, to be installed upstream of the connector, and a union or a flange connection must be installed downstream of the shutoff valve. Again, this facilitates disconnection, safe disconnection of the appliance itself from the gas supply. Additionally, the shutoff valve is permitted to be accessibly located inside or under the appliance. So again, it's important for the product inspector to review the cut sheets for each of these gas supplied appliances to see exactly where this accessible shutoff valve is located, because it is certainly possible that it is designed into the system and it is located accessibly inside or under the appliance. Section 1212.6.2 of the California Plumbing Code addresses in a little bit more detail requirements for sediment traps installed on fuel gas piping. The sediment trap is required to be obviously installed downstream of the appliance shutoff valve, because this particular device or component, it does require periodic maintenance, and the gas supply is required to be shut off prior to this maintenance. The sediment trap is required to be installed as close as possible to the appliance inlet. It's supposed to be installed before the flex connector, and it is required to be installed per the figure that you can see on the right hand side of this slide, which is figure 1212.9. And it's also acceptable to use another recognized device. But again, if that's the case, the design professional is going to identify what that is and show a very detailed look of what the actual device to be implemented or installed in the system is. Okay, now we're going to discuss the required protocols for pressure testing, inspecting, and purging of fuel gas system lines. A visual inspection, obviously, and pressure tests are required of all fuel gas piping systems. The project inspector must witness the piping system pressure tests. Valves are not to be used for bulkheads during any pressure testing unless the valves themselves are designed to withstand pressure test pressures. Only air, nitrogen, carbon dioxide, or another inert gas is permitted as the test medium. Oxygen is never to be used as a pressure test medium in a fuel gas system piping pressure test. Also, obviously, all pipe joints are required to be left exposed during testing, because obviously that's the only place that the piping is, well, not the only place, that is the most common place that the piping system is going to have leaks, and the only way to detect the location of those leaks is to have those joints exposed. Continuing with the requirements for fuel gas piping pressure testing and inspection, all valves at unused outlets must be closed, plugged, or capped. Again, the requirement for capping or plugging all outlets is a very important consideration and requirement. Appliances or equipment that are not required to be tested must be isolated from the piping system. The piping system itself must be tested at 10 psi minimum for 15 minutes without any leaks at all. There is an allowance or an additional requirement, I should say, for a 60 psi minimum test for 30 minutes minimum for any welded piping or fuel gas piping that's carrying working pressures in excess of 1/2 psi. Corrugated stainless steel tubing carrying working pressures in excess of 1/2 psi require 30 psi minimum test for 30 minutes minimum without showing any leakage. Obviously, in the event that any leakage is identified, those leaks have got to be verified and their locations corrected. So retesting of any affected portion is required following any repair or replacement of defective piping. So certainly a leak test is going to be required in the event that a pressure test fails. So in the event that a pressure test has failed and the leaks have been potentially corrected, the affected portion of the piping itself must be retested following any replacement or repair. A test for leaks after the gas is turned on is also required, and installation or unisolation of appliances and equipment must also occur. So after the piping itself has been tested, after the test has been verified successful, after the appliances have been reconnected to the piping system, another test for leaks must be conducted. A certificate of final inspection is then generated once no leaks have been detected in the system or with the appliances, and this particular final inspection certificate must be generated and then issued to the serving gas supplier, as we discussed earlier in section 1204.0. Section 1213.6 discusses purging requirements for fuel gas piping systems. Piping is required to be purged outdoors for a variety of situations. Number one, when the operating gas pressure exceeds 2 psi or the piping meets the size criteria found in table 1213.6.1, the piping is required to be purged outdoors. In situations where existing gas piping has been opened or removed from service, the piping is required to be purged outdoors. In situations where gas piping is placed in operation and the air has been purged with inert gas, then the inert gas is purged with fuel gas, which must be purged outdoors. Continuing with the requirements for purging fuel gas piping outdoors, at the point of discharge where the purging is going to occur, it must be controlled by a shutoff valve, and this area is required to be continuously attended and monitored with a combustible gas indicator. Also, the outlet where the purging is going to exit the piping must be located 10 feet minimum from any openings, any ignition source, and any personnel. Additionally, it must be located 25 feet minimum from any air intakes, any HVAC intakes, etc., to the building itself. Also, the purging must be stopped when 90% fuel gas is detected. And again, this requires a combustible gas indicator, which would actually give some data indication as to what the percentage of fuel gas is being detected is. This image on the right-hand side of this slide shows a common combustible gas indicator, and as you can see by looking at it, there is an LED display dial where data is actually displayed. So this actually provides an accurate indication of the concentration of the fuel gas that's being detected. These detectors are listed, they have to be calibrated, and they've got to be capable of detecting the presence and concentration of fuel gas. So not just the presence of fuel gas, but also some data which expresses the actual concentration. The numerical display must provide a volume scale from 0 to 100% in 1% or smaller increments. So again, it's important to understand that this is the type of indicator that's required when purging outdoors. Continuing with purging requirements, piping is permitted to be purged indoors or outdoors under certain situations. One of them is when the operating gas pressure is less than 2 psi and the piping does not meet the size criteria we discussed earlier in table 1213.6.1. It may be purged with fuel gas discharged to the outdoors, okay, and also it may be discharged indoors through the appliance burner or the burner designated for it. When piping is permitted to be purged indoors or outdoors, it may be discharged indoors and monitored with a simple combustible gas detector. It can also it's also permitted to be purged by the gas supplier, and appliances or equipment must be purged before placing in operation. The purging is stopped when fuel gas is detected. This picture shows a couple of simple gas detector methods. Again, to understand the distinction between gas detection and gas indication, a gas detector can be as simple as what's shown on the left-hand side, just some sort of soapy liquid, because again, the only function of a gas detector is to actually identify that something is actually leaking. There's no qualification, there's no pressure verifications, there's no concentration verifications. It's just a simple indicator that gas is leaking. So the combustible gas detector, okay, that is also shown on the right hand side, which is actually a device, an electronic device. Okay, to summarize, the 2019 California Plumbing Code, plumbing inspection overview topics. We have covered the governing standards, applicable references, appropriate form DSA 152 items, including the DSA 152 manual topics which may be appropriate for review. Chapter 2, which covered definitions. Chapter 3, covering general regulations. Chapter 4, which covered plumbing fixtures and fixture fittings. Chapter 5, which covered water heaters. Chapter 6, covering water supply and distribution. Chapter 7, which deals with sanitary drainage. Chapter 8, which addresses indirect wastes. Chapter 9, which identifies venting requirements. Chapter 10, which discusses traps and interceptors. Chapter 11, which deals with storm drainage. And finally here, Chapter 12, fuel gas piping. Well, that concludes our Project Inspector Overview training module for plumbing. And I appreciate your patience and I appreciate your diligence in and your attention to detail with respect to all of the issues and all of the construction components that you engage in inspecting. And I want to leave you with, again, probably the most important statement and credo to hold near and dear, which will unquestionably make each of you a better project inspector tomorrow, which is read every word and every symbol on every plan and specification sheet for every project every time. I guarantee you, if you make this a regular way of life, you will become a better inspector immediately. Again, thank you again. My name is Jim Gibbons. I'm a construction supervisor too with the Division of the State Architect, and it's been my pleasure to assist in making all of you better inspectors. Thank you.